Okay, so we are back with homework number 2 for Math 96. And don't pay attention to the due date that's listed at the top of this thing. I just recognize that those are there. Follow what's in our course plan, please. And so what we've got, starting off, there's a little bit of teaching I need to do before we can actually do anything with this. And it's this idea of how we handle negative exponents to make them positive. And so let's say that we had something like x to the negative 5. X to the negative 5, if it was a fraction, would be the same thing as x to the negative 5 over 1. Now, in order to make an exponent positive, what we have to do is move it from the numerator to the denominator, or vice versa, from the denominator to the numerator, whichever is the opposite of what it is. So I would move that x to the negative 5 to the denominator, and it would become x to the positive 5. And then a 1 would be left in the top, and I would have 1 over x to the 5th. So if we had something like x to the negative 5, again, recognizing that that's really x over 1, to make the exponent positive, I need to move it to the denominator. Alternatively, if we had something like 3 over x to the 4th, x to the negative 4th, and I wanted to make that exponent positive, I just need to move that whole thing, the x to the negative 4, to the numerator, and we would end up with 3x to the positive 4. And I could put that over 1, but then I would just end up taking away the over 1 anyway because it's not necessary. So that's just a quick, simple intro to the idea that if we want to have positive exponents, we need to take whatever has a negative exponent on it and move it to the other side of the fraction bar, whether it's from the numerator to the denominator or from the denominator to the numerator. That being said, let's move on to number 1. So we have right now a negative in parentheses 2 to the power of 0. And things like this always used to trip me up. What we need to recognize is that what's really happening here is that this is really a negative 1 times 2 to the power of 0. That negative in front is a negative 1 being multiplied by whatever it is that remains. And so anything to the 0 power is 1, so 2 to the 0 power makes 1. But we still have that negative 1 in front being multiplied by it, which is going to cause us to get a result of negative 1. Now, the second part of number 1 is different. That negative is inside the parentheses. So this whole thing, including that negative symbol, is being raised to the 0 power, and anything to the 0 power simply is 1. Okay, I'll pause here for a moment and move on to number 2. So number 2, I'm actually redoing this entire video because of number 2. I did number 2 the very long and drawn out way that shows everything that's happening through the process of this, and it was just sort of a mess, and I didn't like it. There's something to remember about negative exponents that's just kind of a rule that will help you. So if a fraction is being raised to a negative exponent, take the reciprocal, which means to flip the fraction, and make the exponent positive. If I was you, this is something I would keep in my notes. It's a silly rule that really simplifies things in certain cases, including the case of number 2 and what will eventually be number 5. If you go about it the long way, it becomes extremely arduous and kind of a pain. And so I'll demonstrate this for us right now. If we have 2/7 to the power of negative 2, all I need to do to make that negative exponent positive is flip 2/7 over, or take its reciprocal, make it 7 over 2 to the power of 2, and that takes care of it for us. So that being said, we do have 7 over 2 to the power of 2. So as I have done in the past, I'm going to split this up into its two pieces, 7 over 2. times 7 over 2. And I will get 7 times 7 is 49. 2 times 2 is 4. And so we end up with 49 over 4. There is another way to do this that's more proper, in my opinion, but I ended up filling up this entire box with math doing it. And so I thought I would spare you that and just give you the shortcut rule. So it would be a great idea to write down this little trick that I wrote out for you there to the right of that fraction, that if a fraction is being raised to a negative exponent, take the reciprocal or flip the fraction and make the exponent positive, just like we did. I hate that little trick, but it works and saves a lot of time. I'm going to pause for one moment and just double check something and be right back. Okay, so we're good to go. Pause there for a moment and I'll move on to number 3. So with number 3, I have kind of a unique approach to this, and what I would encourage you to do is to recognize that you may feel the urge to begin canceling things like c to the negative 2 and c to the negative 6 and think, oh, I could do like c to the negative 4 because the difference between negative 6 and 2 is 4, and then I would end up with c to the positive 4. Well, that's not going to work, and there's a reason why. And the reason why is because 2 minus negative 6 is really 8, not 4. And so before you start doing any canceling or any of that kind of stuff, it can get really confusing because of the rules around positive and negative numbers if you start trying to do canceling across the numerator and denominator of this fraction. My first step would be to recognize that in order to make positive exponents, my a to the negative 5 needs to go to the denominator. My b to the negative 3 needs to go to the denominator. And my c to the negative 6 needs to go to the numerator. So I would simply take this fraction and move the parts that are going to move right now as my first step. So 30, my a to the negative 5 is going to go to the denominator. My b to the negative 3 is going to go to the denominator. I'm still going to have a c to the power of 2 in the numerator. And so and also what's going to move to the numerator is that c to the negative 6. And so that negative 6 is going to be a positive 6. So then in the denominator, I will have 6a to the 9th is staying. The c to the negative 6 went to the numerator. In the denominator, I'm getting an a to the 5th and a b to the 3rd. So now I can simplify the numerator and simplify the denominator. So I will have 30 a with, or sorry, not a, c. There are 2 c's and 6 more c's makes 8 c's. In the denominator, I'll have a 6. 9 a's and 5 a's makes 14 a's. B to the power of 3. And then the last thing that I need to notice is that I don't have any variables that are common in the numerator and denominator, so there's nothing to cancel there. But I do have a 30 and a 6 that can divide each other and make a 5c to the power of 8 over a to the 14, b to the 3rd. And that's going to be it for number 3. Pretty simple. If we first address moving the negative exponents from the numerator to the denominator or denominator to the numerator, in my opinion, that's the best approach and is the simplest. So that's the way that you'll see me doing it. I'm not sure how Alex does it, but that's what I would do. Moving on. Number 4, we have to recognize that similar to the first homework set, we have all of this stuff here being raised to the power of 2. So I've got 2 of them, and so I'm going to go about it the way that I have in the past, which is writing it all out, because that makes a little bit more sense to me. Okay. There are 2 things that I could do from here. I could just multiply everything together, like multiply the negative 2, multiply the a, and then when I multiplied the b, I would get a negative 12. Then I would have to move that negative 12 to the denominator. I'm a fan of getting all the exponents to be positive, if possible, right away. So that's what I'm going to do. I'm actually going to rewrite this with all positive exponents first. So my b to the negative 6 goes to the denominator in both cases. And then I can see that now I have all positive exponents, and so all I have to do is do the multiplication. And so negative 2 times negative 2 makes positive 4. A to the 4th times a to the 4th is going to be a total of 8 of them. B to the 6th times b to the 6th is going to make b to the 12th. And that's going to be it for this one, but there is another method that I will demonstrate. We could have just gone straight to applying the exponent like I demonstrated in the other homework assignment. But basically we would take everything in here and raise it to the power of 2. And so we would have negative 2 times negative 2 makes 4. A to the 4th to the power of 2, 2 sets of 4 make 8. Negative 6 to the power of 2, 2 sets of negative 6 make negative 12. And then, of course, we would have to deal with that b to the negative 12, and we would get 4a to the 8th over b to the 12th. Again, both methods work. And there is probably another method out there somewhere, but those are the two that I will stick with for now. Feel free to pause, but I'm going to move on to number 5. Maybe. There we go. And so number 5 is very much like number 2 in that we have a fraction being raised to an exponent. And so we want to remember the little trick from number 2. If a fraction is being raised to a negative exponent, take the reciprocal, which means flip the fraction, and make the exponent positive. So we'll bounce back over to number 5, and that's what we're going to do. So our very first thing is going to be to say, hey, we have a negative exponent. That's no good. We're going to take the reciprocal or flip this fraction. So 4z to the 6th will be in the numerator. 3z to the 3rd will be in the denominator. And that will cause that exponent to become positive. I'm going to pause for 1 second and just double check something. Okay, so we are good to go. Make sure it's recording, Schlegel. Okay, good. So as I mentioned, if you have a negative exponent outside the fraction, all you need to do is take the reciprocal of the fraction inside the parentheses, change the exponent to be positive, and life is good. So now, as we have in the past, what I'm going to do is separate this out, 4z to the 6th over 3z to the 3rd. I could cancel these z's right now. I'm just going to wait until I'm finished to do that. So I have 2 sets of these, remember, so 4z to the 6th over 3z to the 3rd. I multiply numerators, I multiply denominators. 4 times 4 makes 16. Z to the 6th times z to the 6th makes z to the 12th. Over 3 times 3 makes 9. Z to the 3rd times z to the 3rd makes z to the 6th. Remember, we add exponents when we are multiplying them together. And so if we were to simplify this darn thing, 16 and 9 do not have any common factors, but we do have a z to the 12 and a z to the 6, and so those would divide out. The 6 in the bottom would disappear, and 12 minus 6 leaves 6 in the numerator. So we will have 16 z to the 6th over 9 as our final answer for this one. And I will also show the other way. That's kind of the shortcut to do this. So the alternative method would be to go 4z to the 6th over 3z to the power of 3. And again, you could cancel the z's right off the bat. We can go ahead and do that. We might as well. So that's going to leave 0 z's in the denominator, 3 z's in the numerator, And 4 to the power of 2, we're going to be doing kind of the shortcut method like we have in the past, where you take both of those to the power of 2. So 4 times 4 makes 16. And 3 to the z to the power of 3 raised to the power of 2 makes 3 times 2, which is z to the 6th. And then there are no z's left in the denominator, so 3 to the power of 2 is 9. And that's going to be the shortcut or faster method to get to the same solution that we did in the black writing. Now, again, I do prefer the method that I used in black just because it shows everything. I can see what's happening. But if you prefer a more shortcutty method, that's your prerogative. And with that, I do believe that's the last problem for this homework assignment. I'll zoom back in and leave this here for you to pause if you need to. And that'll be it for this one, folks. I hope this was helpful, and I hope that you have an awesome day.